بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 8. We are in model 5. We are in model 5. Today we have the first lesson in model 5. We want to learn and identify functions. Functions. We want to learn what the meaning of the functions and identify functions. So we want to determine whether or not a relation is a function by identifying the number of outputs assigned to each input. So in this lesson, we want to learn relations and functions. So a mathematical relation exists when two mathematical values are related in some way. So what's the meaning of a relation? A relation is any set of order pairs. A relation is any set of order pairs. So the input of the relation is the set of x coordinates. The output is the set of y coordinates. Relations can be represented as co. So as you see here, we have the ordered pairs x, y, x, y, x, y, x, y, and here we have the table. So the values of x, we have -2, we have 0, we have 1, we have 3. The values of y, 3, -1, 2, 1. The name of x, input. The name of x, input. The name of y, output. The name of y, output. So this graph or this diagram, the name of this diagram, mapping. Mapping include input and output. And this is the relation. So as you see here, input, we have relation between -2 and 3. -2 and 3. We have relation between 0 and -1. 0 and -1. We have relation between 1 and 2. We have relation between 3 and 1. This is the graph. So as you see, -2, 3. -2 in the x and 3 in the y. This is the first point. Then we have 0, -1, the second point. Then we have 1, 2. This is the third point. Then we have 3, 1. This is the fourth point. So this is the meaning of the relation, the input, the output, and the mapping. And this is the graph for this relation. So what's the meaning of the function? Our lesson. What's the meaning of the function? A function is a specific type of relation. A specific type of relation that assigns exactly one output to each input. Exactly one output to each input. So as you see here, we have two kinds of relation. Here, the first relation, function, and the second relation, not a function. What is the difference between them? In the first relation, as you see, we have one output each input. Means 2 just have relation with 1, 4 just have relation with 3, 5 just have relation with 4, 9 just have relation with 7. So this is a function because each value is paired with exactly one output value. So the second type, not a function. Why? Because of 2 has two relations with one and with 3. So this is not a function because 2 in the input is paired with 2 output values, 1 and 3. So this is not relation. Must to be the element in the input relation with one element in output. If the element in input have relation with two elements in output or more than, means this is not function. This is not function. This is the difference between the function and not function. Identify functions using mapping diagrams. A mapping diagram can be used to determine whether the relation is a function. So as you see here, mapping diagram function here, mapping diagram not a function. Here function because each element from input has relation with one element in output. But here not function because we have one in the input has two relations with the two elements in the output. So this is not function. This is not a function. So the mapping diagram label that the function shows the input 1. The input 1 is mapped to both 3 and 5. 3 and 5. Because an input value is mapped to more than 1. We have here 2. More than 1 output. So the relation is not a function. Identify functions using mapping diagrams. For example, determine whether the relation is a... Explain. عليكم السلام ورحمة الله وبركاته. As you see in this input, from element 1, we have two mapped or two relations between 1 and -1. So more than 1, the relation more than 1 means not function, not function. So check each input value. If the input value is mapped to more than 1 output value, then the relation is not a function. So the relation is not a function because the input value 1, the input value 1, this element, is mapped to more than one output value, mapped with 1 and -1. So this relation not function. And in this example, determine whether the relation is function and explain. Look to the input. 2 mapped with 1 element. 4 mapped with 2 elements. Mapped with -5 and mapped with -4. So more than 1. So this is not function. This is not function. So the relation is not function because the input value 4 is mapped to more than 1 output value. Identify functions using tables. Tables can be used to represent relations and functions to determine whether a relation shown is a table. In a table is a function. Consider how the members of the input correspond to the members of the output. Look to this function and this. Look to this table. Sorry, the first table we have function. This table includes input the values of x and output the values of y. As you see here, we have 1, 2, 2, 4, 3, 6, 4, 1. And each element from input have just one relation with one element in output. Means this is a function because each member of the input corresponds to exactly one one member of the output. In the second table, this is not function. Why? We have here the input and here the output. As you see, we have 1, 2, and here 1, 2. Means we have one element in the input correspond or lab or have two relations or mapped with two elements in the output. So this is not a function because members of the input correspond to more than one member of the output. This is specifically one. As you see, one mapped with 2 or correspond with 2, and 1 also correspond with 4, and also 3. 3 with 6, and the same number with 8. To both 2 and 4, and 3 corresponds to both 6 and 8. So this is not function. Identify functions using tables. Determine whether the relation shown in the table is a function. Explain. This is the input and this is the output, and we want to determine if this relation function or not. So as you see here, we have -2 and 4, 2 and 4, -3 and 9, 3 and 9. So each element inside the input just have one relation with the elements in output, means this is function. So study the table. Are there any input x values that correspond to more than one output value? No. -2 just have with 4, 2 just have with 4. -3 just have with 9, and 3 just have with 9. So the relation is a function because each input value corresponds to exactly one output value. So the relation is still a function because each member of the input or x value corresponds to exactly one member of the output or y value. In this example, determine whether the relation shown in the table is a function and explain. Look to the input. 1 has one relation with 3, or correspond just with 3. 2 correspond just with 3. 3 correspond just with 3. But here 2 also correspond with 2. So we have 2 has more than relation. More than relation. So means not function. Not function. So the relation is not a function because the input value 2 corresponds to more than one output value. Identify functions using graphs. The order pairs of a relation can be graphed on the coordinate plane. To determine whether the relation shown on a graph is a function, you can apply the vertical line test. The vertical line test. If for each value of x, a vertical line passes through no more than one point on the graph. So then the graph represents a function. If the line passes through more than one point on the graph, it is not a function. To perform the vertical line test, you can use a pencil or a strategy to represent a vertical line. So place the pencil at the left on the graph and then move it to the right across the graph. When you have a graph, look for a point about the vertical line. And as you see here in this line, we have 2 points. We have this point and this point. What is the location of this point? This is -2 in x and 0 in y. And what is the location of this point? This is 0 in x and 1 in y. So must x not repeated in more than point. So the graph is a function because the vertical line test. This is the vertical line test. As you see here, what is the value of x here? 1, 2, 3, 4, 5, 6. Here 6. What is the value of x here? Here 0. What is the value of x here? As you see here, -6. 1, 2, 3, 4, 5, -6. So as you see, the value of x not repeat. The value of x not repeat. We have different value of x. Means this is function. This is function. So that it always intersect the graph at exactly 1 point. So this means that each input corresponds to exactly 1 input. Exactly just 1 input. Perform the vertical line test on the following graph. As you see in this graph, we have here point, we have here point, and we have here point. So the graph is not function y. Right. What is the value of this point? What is the located of this point? And here we have 0 in x, 1, 2, 3, 4, and 4 in y. And here also we have 0 in x and -2 in y. So as you see, the value of x repeated 2 times. When the value of x repeated more than 1 time, means this relation not function. So the graph is not a function because the vertical line test shows that it intersects the graph at more than 1 point. This means that an input corresponds to more than 1 output. For the following graph, refer to the talk about the type. And here we have this point, here we have this point, and we have this point. What is the located of this point? And here we have 2.5 in x, 2.5, and 0 in y. And here we have -2.5 in x and 0 in y. And here we have 0 in x and -3 in y. So the value of x here 2.5, the value of x here -2.5, the value of x here 0. So means the values of x not repeated then or more than 1 time. Means this is function. This is function. So the graph is a function because the vertical line test shows that is always intersects the graph at exactly one point. This means that each input corresponds to exactly 1 output. Identify functions using graphs. Determine whether the relation shown is in the graph is a function? Explain. As you see here, just we have points. We can find the located of each point, then we can compare between input and output, between the values of x. So, what is the located of this point? 2 in x and negative 3 in y. And this point, 3 in x and 1 in y. And this point, 2 in x and 3 in y. And this point, negative 2 in x and 2 in y. And this point, as you see, we have negative 1, 1. Right. Look to the 2 points here. The 2 points here have the same value of x, the same value of input. Means the element 2 corresponds with 2 elements, with a 3 and with negative 3 at the same time. So means this is not a function. This is not a function. So use the vertical line test. The relation is not a function because the input 2 corresponds to more than one output. And in this example here, determine whether the relation shown in the graph is a function or not. So at the first, try to find the located of each number, of each point. So as you see here, negative 3 in x and negative 1 in y. And here negative 2, 1. And here 1 and 2. And this point 2 in x and 3 in y. And this point 3 in x and negative 2 in y. Compare the values of the x. Here we have 2, here 1, here 3, here negative 3, here negative 2. Means each element inside the input correspond or maybe just with one element in the output. So that means this is function. This is function. So the relation is a function because each input value corresponds to exactly one output value. Identify function using graphs. Determine whether the relation shown in the graph is a function, and explain. So as you see in this graph, use the vertical line test. On the graph of the line, does the vertical line pass through more than one point? So as you see here, each point have different value in the x. Each point from this line have different value from the x. So means no. So means the relation is a function because each input corresponds to exactly one output. In the second example here, determine whether the relation shown is the graph is in the graph is a function. Explain. طيب, as you see here, we have this point and this point have the same value of x, 1 in x, 1 in x. And as you see here, we have this point and this point and this point also have the same value on x, -1. Means this is not function because we have element in the input have corresponding more than element in output. So the relation is not a function because at least one input corresponds to more than one output. So as you see, this point have an x1. This is 1 in x. And this point and this point and this point have -1 in x. So means one element, it means as you see here, we have this point about 1 and -1.75. 1 and -1.75. And this point 1 in x and about 0 negative 0.25. And this point 1 in x will be in the y2. So as you see here, the same element in the x, the same value in the x have relation with the 3 elements in the y, have relation with the 3 elements in the y. So it means this is not a function. This is not a function. So this is our lesson today. This is the meaning of the relation, the function, and how to identify the relation. Is it a function or not? Using data, using mapping, using the table, and using the graph. Who has any question about this idea? Is it this lesson clear for all? No questions? Girls, no questions? Are you hearing me? Are you here with me? Okay, fine. So this is for our lesson for today. Each lesson we want to take a new lesson, and we want to do a training for the MSAT exam. We have in 27 in this month we have exam. The name of this exam, MSAT exam. This exam to evaluate you in the previous stage in mathematics. So we want to do training about this exam. And before we start, MSAT math advantage score. The exam of MSAT from grade 4 to grade 10. Grade 4 and 6 and 8 and 10. The perfect score, the full score will be 1050. And if you get between 875 and 150, means you have exceeds expectations. And here we have the average for each mark. And if you get between 125 and 225 means below expectations. Below expectations. So grade achievement levels. We have level 1, level 2, and level 3, and level 4. Each level meaning level 1, the students ability is 3 and 4 grade levels behind the expectation for her or his grade. So the student is very unlikely to achieve the required level of performance by grade 12 without extraordinarily intense and sustained effort. And here each level may have a meaning. For example, level 2, the student ability lages 1 to grade level behind the expectation for her or his grade. So the student will need to improve her or his ability at an accelerated rate if she or he is to achieve the required level of performance by grade 12. Level 3, the student's ability in this subject is one track for her or his grade level if the student continues to keep pace with the rising performance expectations in subsequent grades, she or he is likely to achieve the target level of performance in grade 12. And the level 4, the high level here, the student's ability in this subject is above the expected level for her or his grade. So the student likely has the ability to engage productively with a higher level material. Okay. طيب هلا the test duration the time 50 minutes 50 minutes and the question grade 8 and 10 50 multiple choices question you have 50 multiple choices question content areas we want to make training about number and quantity algebra geometry and measurement and statistics. Task type, multiple choice, multi-select, fill in the blank, fill form, list and drag and drop. And the time for grade 8, 27 in this month, and 30 in this month, and 31 in this month. Suppose in 27 or in 30 or 31 your MSAT exam. Okay? So I want from all to make training with me and to prepare yourself to this exam. طيب. So, as you said previously, what's the meaning of the MSAT? MSAT is a test, a math test, evaluate the student on the previous stage in mathematics to know what is her or his level. طيب. This video here, sheep's names. Let us to see together.
In this video, we're going to look at the names of two-dimensional shapes. Now, there's lots of different types of two-dimensional shapes, so I'm going to start off talking about polygons. And polygons are two-dimensional shapes with straight sides, and then I'll talk about some of the other popular ones that you'll need to be able to name in maths exams. So let's start off by looking at a polygon, which has got three straight sides, and that would be a triangle. There's lots of different types of triangles, and if you look at the video on types of triangles on Corporate Maths, you will see all the different names such as equilateral, isosceles, scalene, etc. But here, this is just a triangle is a shape with three straight sides. A shape with four straight sides is called a quadrilateral. Again, there's different types of quadrilaterals, and if you look at Corporate Maths and you look at the video on types of quadrilaterals, you'll see all the names such as square, rectangle, and so on, rhombus, trapezium, parallelogram. But a shape with four straight sides is called a quadrilateral. With five straight sides, it's called a pentagon. Just like the building in America, which looks very similar to this, it's got five straight sides. So a pentagon is a shape with five straight sides. Next, this shape with six straight sides is called a hexagon. Notice the word six has got the letter X in it, and so does hex. Okay, so hexagon is six straight sides. Next, seven straight sides is called a heptagon. Just like the heptathlon in the Olympics, which Jennifer Ennis won gold in, a heptagon has seven sides. A heptathlon has seven events. So seven sides is called a heptagon. Eight sides is called an octagon. Now, I'm sure you've heard of this one before. Octagon, similar to an octopus, which has 8 tentacles. So an octagon has 8 sides. Let's look at a couple more. Here we have got a nonagon. A nonagon has 9 straight sides. If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's called a nonagon. And a decagon has got 10 straight sides. So it's 10 straight sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's called a decagon. Now there's names for 11, 12, and so on. And some of them are really quite funky. And if you look them up online, you'll see the names of them. There's even songs which you can sing to remember all the different names of polygons. But they're the most common ones that you're going to be able to name in the exams. Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. Let's have a look at some other two-dimensional shapes that don't have straight sides. So here is a circle. So obviously you need to know the name of that. That's called a circle. Another one which you may be asked in the maths exam would be a semicircle. There's other ones which you may encounter, and if you're ever in doubt, just look them up online. But these are some very common ones that you'll need to know the names of in maths exams.
Do you have any question about the name of 2D shapes? Clear for all?
Yes.
In this video, we're going to look at the names of two-dimensional shapes. Now, there's lots of different types of two-dimensional shapes, so I'm going to start off talking about polygons. And polygons are two-dimensional shapes with straight sides, and then I'll talk about some of the other popular ones that you'll need to be able to name in maths exams. So let's start off by looking at a polygon, which has got three straight sides, and that would be a triangle. There's lots of different types of triangles, and if you look at the video on types of triangles on Corporate Maths, you will see all the different names such as equilateral, isosceles, scalene, etc. But here, this is just a triangle is a shape with three straight sides. A shape with four straight sides is called a quadrilateral. Again, there's different types of quadrilaterals, and if you look at Corporate Maths and you look at the video on types of quadrilaterals, you'll see all the names such as square, rectangle, and so on, rhombus, trapezium, parallelogram. But a shape with four straight sides is called a quadrilateral. With five straight sides, it's called a pentagon. Just like the building in America, which looks very similar to this, it's got five straight sides. So a pentagon is a shape with five straight sides. Next, this shape with six straight sides is called a hexagon. Notice the word six has got the letter X in it, and so does hex. Okay, so hexagon is six straight sides. Next, seven straight sides is called a heptagon. Just like the heptathlon in the Olympics, which Jennifer Ennis won gold in, a heptagon has seven sides. A heptathlon has seven events. So seven sides is called a heptagon. Eight sides is called an octagon. Now, I'm sure you've heard of this one before. Octagon, similar to an octopus, which has 8 tentacles. So an octagon has 8 sides. Let's look at a couple more. Here we have got a nonagon. A nonagon has 9 straight sides. If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's called a nonagon. And a decagon has got 10 straight sides. So it's 10 straight sides, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's called a decagon. Now there's names for 11, 12, and so on, and some of them are really quite funky, and if you look them up online, you'll see the names of them. There's even songs which you can sing to remember all the different names of polygons, but they're the most common ones that you're going to be able to name in the exams. Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. Let's have a look at some other two-dimensional shapes that don't have straight sides. So here is a circle. So obviously you need to know the name of that. That's called a circle. Another one which you may be asked in the maths exam would be a semicircle. There's other ones which you may encounter, and if you're ever in doubt, just look them up online. But these are some very common ones that you'll need to know the names of in maths exams.
Okay, inshallah, each lesson we will make training and revise for these ideas to train you, to prepare you, to be ready, inshallah, in the IMSAT math exam. طيب, do you have any question? Okay, this is our video today. Thank you for your listening. Have a nice day. See you tomorrow, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.